Okay, so this is part 3 or the third page of the semester 2 geometry final review. So 33 here is asking, write the tangent ratios for P and angle Q. So let's start with angle P. Let's circle. First thing though, let's label the hypotenuse. So hypotenuse is across from the right angle. It's along the side. So 29 is our hypotenuse. P is the angle we're looking at. So next to is the adjacent. So 21 is adjacent. And across from is 20, so 20 is opposite. Tangent for P is going to be opposite over adjacent. Okay, opposite side is 20, adjacent side is 21. So it's going to be 20 over 21 is going to be your ratio for angle P, your tangent ratio for angle P. Your ratio for angle Q, so again, this is adjacent for P and opposite for P. Okay, but we got to erase it and start over with Q. Okay, so our hypotenuse stays the same, but this time we're using Q. Next to Q is 20, so this is our adjacent. So it was opposite for P, but it's adjacent for Q. And then 21 is across, so that one's going to be opposite. Okay, tangent, okay, at Q is going to be opposite over adjacent. Opposite is 21. Adjacent is 20. So that's going to be the ratio on that Q. 34 is asking the same thing, except for Y and Z. So we know, so let's start with Y. Okay, this is hypotenuse across from the right angle. Circle our angle Y. Next to is adjacent. Across from is opposite. Tangent, again, it's so katoa. Okay, so tangent is opposite over adjacent. So tangent at Y is going to be opposite over adjacent. Opposite is 7, adjacent is 6. So Y. Let's erase. Okay. Now we're going to do Z. So hypotenuse stay the same, Z. Next to Z is the adjacent. Across from Z is the opposite. So tangent at angle Z is going to be opposite adjacent, which is going to be 6 over 7. 6 is opposite, 7 is adjacent. Okay. So we label hypotenuse first, circle the angle, then label the next two side adjacent, and across from the opposite. And number 35, we want to find the value of x, round to the nearest tenths place for both of these, for 35 and 36. Okay. So first thing, we want to label our hypotenuse. So this is our hypotenuse. Second step is to circle our angle. X is next to the angle, so that's adjacent. 9 is across from the angle, so that is opposite. So katoa. So katoa. Okay. We are looking at opposite and adjacent. So again, we're going to have tangent. So tangent of theta equals opposite over adjacent. Okay, so our angle is 20, so it's the tangent of 20. Equals opposite is 9, adjacent is x. Okay, now we got to solve for x. So we got to get x by itself. So right now x is in the denominator, so we got to get it out of the denominator. We get it out of the denominator by multiplying both sides by x. Okay, if you multiply one side by something, you got to multiply the other side by. So those x cancel, and we get x times the tangent of 20 equals 9. Okay, to get x by itself, we now need to divide both sides by the tangent of 20. Okay, so the tangents of 20 cancel out, and we get x equals 9 divided by the tangent of 20. So if we take our calculator here, okay, we're going to have 9 divided by the tangent of 20, and that's going to be 24.7. So nearest 10th place, 24.7. We're rounding to the nearest 10th, so it was 24.727. So 2 is less than 5, so we're going to stay at 7. Okay, 36. Label again one side and one angle here. Okay, so we're solving for a second side. So we're using trig, regular trig. So this is hypotenuse. So I think it was the part 2 we mentioned this, but if you have two sides of a right triangle and you're solving for the third side, use the Pythagorean theorem. A squared plus b squared equals c squared. If you're solving for an angle, use one of the inverse trig functions. Inverse sine, inverse cosine, or inverse tangent. If you have one side and one angle and are looking for a second side, like we are in this problem, you're using one of the regular trig problems. So sine, cosine, so okay, label hypotenuse first. Second step, circle the angle. Next to is adjacent. Across from is tangent. Across from is opposite. I don't know why all these end up being tangent, but this is going to be tangent because we have opposite and adjacent. Who made this? Oh, I did. Not all of it, actually. I didn't pick the problems. I just put them together. I don't know why it's all being tangent. Tangent theta equals opposite adjacent. It's the same process, though. Tangent 55 equals 8.9 over x. Okay. We want to solve for x, so we got to get x by itself. In order to get x by itself, we need to multiply both sides by x. Okay, so we have x tangent 55, 8.9. Then to get x by itself, we divide by tangent 55. So x, these cancel. X is going to equal 8.9 divided by the tangent of 55. So we go to our calculator. 8.9 divided by tangent 55 is 6.23. We want to round to the nearest tenth, so that's going to be 6.2. So x is going to equal 6.2. 37. Find the value of x to the nearest degree. So this one, and again, it's going to be tangent. Whatever. That's fine. So we're solving for an angle, so we're going to use inverse trig. So same process, though. Label the hypotenuse first. Circle the angle. 11 is next to, so that's adjacent. Across from is 19, so that's opposite. So we have opposite and adjacent, which is going to be tangent. So katoa, TOA, opposite over adjacent. And we're using inverse because we're solving for an angle, not a side. So it's going to be inverse tangent of the ratio of the opposite side over the adjacent side is going to be equal to the angle. So inverse tangent, opposite is 19, adjacent is 11, and the angle is x. So we go to our calculator, we go to trig, we go to inverse tangent of opposite over adjacent, so 19 divided by 11, and we get 59.9. It wants us to round to the nearest degree, so 59.9 is going to round up to 60 degrees equals x. 38. The students in Mr. Collins' class used a surveyor's measuring device to find the angle from their location to the top of a building. They also measured their distance from the bottom of the building. The diagram shows the angle measure and the distance to the nearest foot. We want to find the height of the building. So he had he measured. They used a surveyor's measuring device to find the angle to the top of the building. So the measure the angle from where they were standing to the top of the building was 72 degrees. They measured the distance from them to the bottom of the building is 100. They want to find the height to the nearest foot of the building. So the height of the building we can call x. Okay. So here's our right triangle. Label your hypotenuse first. Circle your angle. Next to is adjacent. Across from is opposite. We have opposite and we have adjacent. So we're going to use tangent. We're solving for a side. So it's regular tangent. So tangent of theta equals opposite over adjacent is our equation. Our angle is 72 degrees. Our opposite side is x. Adjacent side is 100. We want to get x by itself, so we want to get 100 out of the denominator. So we multiply both sides by 100. Multiply by one side, you got to multiply to the other. So we have 100. 100, as some of you might say. Times 70, tangent of 72. Okay, and that's going to be 307.768. We want the height to the nearest foot. So that's going to be 307.768 is going to round up to 308 feet. The 0.7 is going to round it up from 307 to 308. Okay, 39. Want to write the ratios for sine and cosine here. For sine A and cosine of A. So first thing we want to do is label our hypotenuse. Okay, then we want to circle our angle. So let's do sine A first. So A. So next to is adjacent. Across from is opposite. So sine, right? So Katoa. Sine is going to be opposite over hypotenuse. So sine of A is going to be opposite over hypotenuse. Opposite is 3, hypotenuse is 5, so it's going to be 3 over 5. Then they want the cosine of A. So cosine of A is adjacent. Cosine is adjacent over hypotenuse. So the adjacent is 4 and the hypotenuse is 5. 4 over 5. Okay, so here's our ratio. Ratio for sine A is 3 over 5. The ratio for cosine A is 4 over 5. 40. Find the value of x, round to the nearest degree. Okay, so what we want to do here is label our hypotenuse first, circle our angle. Adjacent is next to, nothing's there. Across from is 7, so 7 is opposite. We're solving for, again, we're still using SOHCAHTOA. We're solving for an angle, so it's going to be inverse. Okay, but we have opposite and hypotenuse, which is going to be sine. So it's going to be this. Again, we're solving for an angle, so we're using inverse, though. So really, sine of theta is opposite over hypotenuse, but we don't want a side, we want an angle. So we got to use the inverse sign here. So the inverse sine of the ratio of the opposite side over the hypotenuse is going to equal the angle, which is x, or let's call it theta, okay, for the angle. So that's our equation. So then for us in our example here, we have the inverse sine of opposite over hypotenuse, so 7 over 15. It's going to be equal to, and the angle was x. So inverse sine where's the tab? Calculator froze. So the inverse tangent inverse sine of 7 divided by 15. It's going to be 27.8 to the nearest degree. So 27.8181 is going to round to 28 degrees. The 0.8 is going to round us up to 28 degrees. 41. Okay, label the hypotenuse. Circle the angle. 11 is next to, so that's adjacent. We have so we have adjacent and hypotenuse. That's going to be cosine. So our formula is cosine of theta equals the opposite over the adjacent side. So the angle is 28, so it's going to be the cosine of 28 equals, adjacent over hypotenuse. The adjacent is 11, the hypotenuse is x, so 11 over x. We want to solve for x, so we got to get it out of the denominator. We do that by multiplying both sides by x. Okay, and we get x times the cosine of 28 equals 11. Then to get x by itself, we divide both sides by the cosine of 28. So we get x equals 11 divided by cosine of 28. 11 divided by cosine 28 should be 12.4583. We're going to round to the nearest tenth. So we're going to round 45 to 5. So it's going to be 12.5. That's going to be our x value, our hypotenuse there. 12.5. Okay, 42. Okay, same thing here, or it's not same thing, but similar, very similar. Okay, let me write SOHCAHTOA up there again. SOHCAHTOA. Okay. So we want to label our hypotenuse first. The x is the hypotenuse. Circle the angle. Nothing's next to it, so we don't have an adjacent side. Across from is 18, so 18 is opposite. We have opposite and hypotenuse. That is sine. So our equation is sine theta equals opposite over hypotenuse. So the angle is 35, so the sine of 35 is going to equal 18 over x. Multiply, again, you got to get x by itself. So in order to get x by itself, first needs to get out of the denominator. To get it out of the denominator, we multiply both sides by x. X sine 53 equals 18. Then to get x by itself, we divide by sine 53 on both sides. So we get x equals 18 divided by the sine of 53, and 18 divided by sine of 53 is 22.5384. Do we have directions on here about rounding? Yep, round to the nearest 10th place. Okay, so I got 22.538, so that's just going to be 22.5. 22.5. This one here, label the hypotenuse first, circle the angle. This is going to be opposite. It's across, so it's opposite. Adjacent is next to. We don't have anything there. Okay. We have opposite and hypotenuse, so again, we're going to use SOA, sine, SOA, SOH, opposite hypotenuse. Okay, so sine theta equals opposite over hypotenuse. So the sine of 20 is going to equal opposite is x, hypotenuse is 18. We want to get x by itself. In order to do that, we got to get 18 out of the denominator here. So we got to multiply both sides by 18. So 18 times the sine of 20 is going to be equal to x. So 18 times trig sine 20, 6.15636. So they want to the nearest tenth. So 6.15 is going to get rounded up to 6.2. Number 44. How many left on this section here? Oh, we still got another page. 44 here. So they give us a nice diagram, and they want us to find the length of x. A couple of different ways to do this. Easiest way is to, I guess we assume these are parallel, right? That would make sense. That's prudent, a prudent assumption to make. So that means this is going to be a 90-degree angle. So 90 minus 10 is going to give us 80. So we can then use this right triangle, okay, with an angle of 80. Okay, you could also put a line here and say this is 200. Okay. But let's do the other way. Let's say this is a right angle. Okay, and so 90 minus 10 is going to be 80. They're complementary. Okay, so now we have this right triangle. Maybe. So first thing we want to do is we want to label our triangle. So across from the right angle is the hypotenuse. Circle the angle. Next to it is the adjacent. Okay, there's nothing across. That would be opposite though. Okay, so SOHCAHTOA. We have adjacent and hypotenuse, so we're going to use cosine. So the cosine of theta is going to equal adjacent over hypotenuse. So our angle is 80 degrees. So cosine of 80 equals 200 over x. Adjacent over hypotenuse. Adjacent is 200. Hypotenuse is x. We got to solve for x, so we got to get it out of the denominator first. So we multiply both sides by x. Okay, so we have x cosine of 80 equals 200. We can then divide both sides by the cosine of 80. Okay, and we get canceled. So we get x equals 200 divided by the cosine of 80. Oh, gotta put that in the calculator. Cosine of 80. That is, we're rounding to the nearest tenth. So I got 1,151.75. So the 5 is going to round that 7 up to an 8. So I'm going to get x equals 1151.8. Yeah, I don't know. I'm not sure about how it's settings for rounding. If maybe they truncated it, maybe it was 748 or something. I don't have enough information. Probably should change the settings on this, but that's okay. All right. Okay, and then 45. Okay. To find the height of a pole, a surveyor moves 210 feet away from the base. of the pole, and then with a transit 5 feet tall, measures the angle of the elevation to the top of the pole to be 35 degrees to the nearest foot. What is the height of the pole? So again, the first thing you want to read through, as I just did. Okay, did I remember anything I read? Not really. Okay, and then second time you read through, you want to pick out the pieces and draw as you go along. So to find the height of a pole, so we want to find the height of a pole. Here's our pole. This is our pole. A surveyor moves 210 feet away from the base of the pole. So the base of the pole is down here. The surveyor moved 210 feet away from the base of the pole. And then with the transit, 5 feet tall, he measures the angle. So a 5 foot tall transit, 5 feet. He measures the angle of elevation to be 35 degrees. So angle of elevation to be 35 degrees. To the nearest foot, what is the height of the pole? Okay, so again, you're imagining a large pole. Okay, some guy's 210 feet away. And then he has another little transit device. Again, I'm not really sure what a transit device is, but clearly by the problem, we can tell that it measures angles. Okay, from that, he got an angle of elevation of 35 degrees. Okay, we know it was 5 feet tall, so that's 5 feet tall. The significance of that is not important. Well, it is important. Okay, but we know this is also then going to be 210. Okay, so that's my better drawing, my improved drawing. Okay, so first thing you want to look at is this right triangle right here. Okay, so this is the right triangle. And we want to solve for the height, or we want to solve for x right now. Okay, the height of the pole is going to be x plus 5. Let's find x, and then we can add 5 to it. As I scratch my eyelash here. Okay. So we have, again, this triangle. I'm just going to draw the triangle again one more time. X, 210, and 35. Want to label the hypotenuse first. Circle the angle. Adjacent is next to. Opposite is across from. So we have opposite and adjacent. So that's going to be Kinso Katoa. That's going to be tangent, opposite, and adjacent. So tangent theta equals opposite over adjacent. So that's tangent of 35. Opposite is x, adjacent is 210. We want to get x by itself, so we got to get 210 out of the denominator. So we multiply both sides by 210. 210. Okay, so we get 210 times tangent 35 equals x. So 210 times the tangent of 35 is going to be 147 feet. Okay, so this is 147. We want the height of the whole pole. So we got to do 147 plus the 5, which is going to give us 152 feet. So the height of the pole is going to be 152 feet because we had the extra little 5 foot for the transit. Because he didn't measure from the ground, he measured from the 5 foot tall transit pole. That's 45. 46, we want to find the surface area and volume of these figures. Okay, surface area and volume. Okay. They're giving us this length here as 6. That doesn't make any sense, but we're going to go with it. The reason it doesn't make any sense is because 3 squared plus 5 squared is not going to be 6 squared. Yeah, let's just go with it. Doesn't make sense. You can't have 3 squared plus 5 squared equals 6 squared, but let's just go with it. Let's go with it. Okay. So volume and surface area. So surface area of a triangular prism. So we have 5 sides to a triangular prism. We have the 2 triangular bases. And then we have 3 rectangles. How are you doing on time? 30 minutes? Okay, so we have 2 triangular bases and 3 rectangles. Okay, so we got to find surface area. We're going to need to find surface R, surface area, not surface R. Okay, so area of a triangle is 1/2 base times height. For our triangles, we have a base of 5 and a height of 3. So area is going to be 1/2 3 times 5, which is 7.5. Okay, that's going to be the same as this triangle up here. So that's going to be 7.5 plus 7.5. So that's the area of the 2 triangles on the end. Okay, but we also have 3 rectangles, all of which are going to be different sizes. We have the rectangle on the bottom, which is 5 by 36. So the area for a rectangle is length times width. So 5 by 36. That's 150 times 180. That should be 180. I'll just make sure I do it in the calculator so I don't look like an idiot. 180. Okay. Then we have the rectangle in the back. Purple maybe. That's this rectangle right here. That's going to be 3 by 36. So area of that rectangle is 3 by 36, which is 108. Should be 108, but I'll put it in the calculator just to be sure. Okay, and then we have the rectangle on top, which is 36 by 6. Again, it shouldn't be 36 by 6. It should be 36 by the square root of 5 squared plus 3 squared. So it should be 5.8. 3, but whatever. We can go with 6. So 6 times 36. Which is just going to be 180 plus 36, which is so it's just going to be 216. Okay, so these are the 5. Let me get the black. Okay, so we have 7.5, 7.5. Those are the 2 bases, and then the 3 lateral rectangles are there. So we want to do 7. Add the 5. So there's 5 surfaces on the triangular prism. We have the 5. Let's add them all together. 7.5 plus 7.5 plus 180 plus 180. I'm sorry, plus 108 plus 216, and we get 519. So the surface area is going to equal 519 meters. Oh, we want it in terms of pi. That's not going to matter for a triangle. 519 meters squared. 519 meters squared is area, so it's going to be meters squared. Okay, 47 is a rectangular prism. Oh, we got to do volume. Wait. We got to do volume still. Okay. So the area formula the formula for volume is the area of the base times the height. We know the area of the base was the area of this triangle, so we know it was 7.5. Okay, then we multiply the height. The height is the distance between the 2 bases, so that's going to be times 36. So volume is 7.5 times 36, which is going to be 270 meters cubed. Meter cubed because it's 3-dimensional. Again, if we didn't know the base area already, we know the base of a triangular prism is a triangle, so we could have done 1/2 base of the triangle times the height of the prism. So that might get a little confusing though. So just find the area of the base times the height. 47, we have a rectangular prism here. Okay. So surface area, there are 6 different surfaces, 6 different rectangles here. Okay. So let's do the bottom and the top first. So the area for a rectangle is, again, we're doing surface area. So we have to find the area of all 6 sides and add them together. So top and the bottom here are rectangles, so length times width. So that's going to be a length of 19 and a width of 5. So 19 by 5, which is going to be 95 meters squared. Then we can do the front and the back. Or let's do the right and the left. So the ones on the side. So that's going to be 4 by 5 and 4 by 5. So that's area equals length times width. That's going to be 4 times 5, which is 20 meters squared. Okay. And there's 2 of them, right? 2 sides. So that's 20 and 20. We also had 2, the top and the bottom. So that was 95 and 95. Okay, and the last one we have are going to be the front and the back. So the front here and the back. Okay, so that's 19 by 4. So it's a rectangle, so it's length times width. And it's going to be 19 times 4, which is going to be 76 meters squared. And again, there's 2 of them, the front and the back, so that is 76 plus 76 to find the total surface area here. Okay, we're going to add all those sides together. So we have 20 plus 95 plus 95 plus 76 plus 76. There's 6 sides. The surface area is the area of the whole thing, so we need to add the area of each 6 of the 6 rectangles together. So 20 plus 20 plus 76 plus 76 plus 95 plus 95. 382 meters squared. Then to find the volume. Volume is the area of the base times the height. You can pick any of the 2 sides here to be the base. I always try to go with the top and the bottom. Okay. So the area of the bottom was 19 by 5, which was 95. Okay, and then the height was 4. So it would be 95 times 4, which is going to be 380 meters cubed. Okay. Let me just double check, 95 times 4. Okay. The other way to think of this, again, is the area of the base times the height. We know the base is a rectangle, so we know the area of a rectangle is length times width. So we have length times width times height. Okay, so length times width times height. 19 times 5 times 4, which is going to be 380. Okay. Either way is fine. Okay, cylinder is the next one. Okay, surface area of a cylinder. Again, I think again because we literally just did this in class. A cylinder is comprised of 2 circles and a rectangle. So the top circle, the rectangle, and a circle. Okay. We can imagine a can of vegetables. The top is a circle, the bottom is a circle, and if you take the label off, you unwind the label, you're going to get a rectangle. Okay, so we need to find the area of all 3 of these. So let's start with the circles. Well, area of a circle is pi r squared. Okay. We're given a diameter, so our diameter is 14, and we know a radius is half the diameter. So our radius is going to be 7. So the area of this circle is going to be pi times 7 squared, which is going to be 49 pi. The question wanted us to leave it in terms of pi, so I'm not going to multiply that out to a decimal. I'm going to leave it as 49 pi. We know we have 2 circles, so the area of this circle is 49 pi. This circle is the same size, so it's also going to be 49 pi. Then we want to find the area of the rectangle, okay, which is the unwound label, the lateral area around this cylinder. And we know the height is 15. Okay, but let's just call it h. I'm just going to call it h, the height. Okay, and the distance around the can is the length of our rectangle. So imagine you take that label off. The length of that rectangle is the distance around. The distance around a can or a distance around a circle is the circumference. The formula for circumference is 2 pi r. So if we want to find the area of this rectangle, the area of a rectangle is length times width. The length of this rectangle is 2 pi r, and the width is just simply the height. So 2 pi r h. So it's area equals 2 pi. The radius is 7. The height is 15. So it's going to be 210 pi. Okay, 210 pi. Okay, so if we want to find the total surface area, we want to find the area of the two circles and the rectangle and add them together. So 49 pi plus 49 pi plus 210 pi. Okay, it's going to be 308 pi, and the units here are centimeters squared. Okay, then we want to find the volume. So the volume of a cylinder, just like a prism, is going to be the area of the base times the height. Well, we already found the area of the base. Right? We found it to be 49 pi. Okay, and then we have a height of 15. Okay, so 49 times 15. It's going to be, volume is 735 pi. Okay, and then that's going to be centimeters. Write it smaller. 735 pi centimeters cubed. Okay, the other way we can think of it is the area of the base is a circle, so it's going to be V equals pi r squared h. So that's going to be pi times 7 squared times 15, which is going to give us 735. Okay. Either way works. Pi r squared, or we already know that pi r squared is 49 pi. Okay, last one, area of a cone. So we did not yet do area of a cone, so it's on the review, but since we didn't cover it, probably not going to be on the final, right? Just hint, maybe a little bit. But let's do it anyways because it's on the final. I mean, because it's on the review. So the surface area for a cone is going to be 1/3 pi r. No, surface area is going to be pi r, so it's a circle. So pi r squared is our circle. Okay, then we're going to add pi r times the slant height. Again, we didn't talk about it, but the slant height is going to be 15. So pi r times L. L is going to be the slant height. Okay, so our surface area is pi times the radius is 3, so 3 squared, plus pi times 3 times the slant height, which is 15. Okay, so that's going to be 9 pi plus 45 pi, which is going to give us a surface area of 54 pi. Units here would be centimeters squared. Okay. Let's do volume. So volume is going to be 1/3 pi r cubed. No, pi r squared h. pi r squared h. Because the cylinder is pi r squared h, but we want 1/3 pi r squared h. Okay, so volume is 1/3 pi, the radius is 3 squared. H, we got to find h. So here we have a right triangle. Okay, so this is our h. So hypotenuse, 2 legs. We have 2 sides of a right triangle. We're trying to find the third side. So h squared plus 3 squared equals 15 squared. That's h squared plus 9 equals 225. So h squared is going to equal 216. $14.7. Does it tell us what's let's just leave it as 14.7, I guess. So square root of both sides, h is 14.7. Okay, so 14.7. That's our height, 14.7. So 14.7 times 9 divided by 3. It's going to give us 44.1 pi. 44.1 pi. The units here are centimeters cubed. That's our volume. So 1/3 times pi times 3 times 3 times 14.7. Okay, and if we divide it by pi, 44.1 pi. Yep, so we're good. I think we're good. All right, so that is the third page. We'll end it there. That one was even longer than the other two.